All right, let's begin. Let's first check the status of our app verification from Google. Give me a second. Yeah, cool. We should left to the signal confirmation. All right. Okay. App verification email reply I've done. Now we can begin with some Leetcode maybe. Cool. I'll solve one Leetcode question and then I'll proceed to studying about fine-tuning LLMs. So yeah, cool. To integer array is pre-order and in-order, where pre-order is the pre-order reversal of a binary tree and in-order is the in-order reversal of the same tree constructed on the binary tree. Pre-order you have in-order. Alright, great. So pre-order is center left right, in-order is left center right. Yeah, so we have 3, 9, 20, 15, 7 in order. Okay, so for pre-order my first node will always be the root node. Cool. And for in order I need to find what this root node. So for example, this is my what root node, right over here it is the root node. The left part of this array will be the left side of that tree, the right will be coming on the right. So this goes here 9. This is in order, right? This goes here 9. Pre-order, so I pick it and put it here. For right means this will be my node. These will be my nodes, right? 15, 27, and thus all right. So basically, I get my root node from pre-order reversal, and left node will derive from in order. First left and right. Alright, how can we do it? That's the question. Interesting. Cool, I'm getting pre-order and in order, right? Okay, then what to do? It will kind of get into recursion after this, right? So need, okay, let's just pause it for now. Okay, I need to all right. It's like okay, just get my pen. 3, 9, 10, 20, 15, 7. This is pre. In goes like 9, 13, 9, 3, 15, 20, and 7. You get root node. This goes on left. This part goes on right. This goes on left. Minus done. Then you get 15, 27. Right. Then what do we do? Start as at 0. End as of now of the pre-array is pre-length minus 1. Over here my end is, and then I have this and this. Okay. I get the root node from pre-start. That becomes my root. Pre-start is my root node. Alright. Then I go to left. And get in order. Alright. Uh, okay. So remaining left part will be what? My in root minus in start. This will become my range. Right, so over here it becomes what? Minus in start, and it is 1, minus 1, 0. And okay. I got the end also. यहाँ तक I'll build using left part. Right में I'll take the other part. And of in order where in which search space do I have to search is the thing. It is pre-start plus 1 and pre-start plus remaining left. Alright, let's try this out. So I have at output. What do I get? In order, I put I. ठीक है, and let's make it above. Right. Alright, this is the basic setup of the question solution. Cool. So basically, this function will create my whole route. There have to be some base cases, which is what? Basically, pre start is greater than pre end. Eternal in that case. Right. Next thing we do is cool. I get the route from pre-order traversal. So okay. Okay, now I do have in order का route position, right? I'll get the leftmost node, then I'll get the rightmost node. How do I get the leftmost node? Tree node left, or actually not exactly tree node left, but root dot left will be build tree start plus one, and pre-end will be what? Left के लिए I have to limit the whole end situation, so it will be alright. What do we have over here? I need to see what's the remaining left position or till the ending position. This is not a root position. Left will be what? In order may, right? It will be basically in order root position minus and start. Yeah. So that will be something like in order start. These are the remaining left. Pre-start plus one. It will be pre-start plus remaining left. Okay. I was currently at what? 0. Need to see the end position of this. End will be in this case. Okay, so it will become something like restart plus this. Then it gets in order. Then I need to get in start. In start will be remaining left, of course. Left clear. I need left most part and start. So it will be in order position. Okay, past space, search space. Search space will be basically my start. End position will be, of course, -1 of this. Yeah. ठीक है. Alright, it makes sense, I guess. Let's do one thing. ठीक है, pre-order start के लिए what do I need? Alright, start के लिए I need basically pre-start plus count left plus 1. Alright, and go like this. Pre-end will remain the same. Then I have in order. Start time will be in order root position plus 1. In order plus 1. Go like ठीक है. This would somehow, this should work, I guess. ठीक है. This should work. Let's try it out. Alright, it worked successfully, I guess. And let's check out the solution once.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve a pretty fun problem, construct a binary tree from a pre-order and in-order traversal. So we're actually given two integer arrays representing 1, the pre-order traversal, and 2, the in-order traversal of a binary tree. And our goal is to take these two traversals and the orderings of those nodes and then reconstruct basically the original binary tree that the traversals are from. And it is technically possible. These two traversals have all the information we need. We just need to take that information and then deconstruct it and then reconstruct this binary tree from those. So just to verify it, let's go through the pre-order to left pre-order traversal. We run with now traversal, so we still need the values in the traversal. Now to the left subtree. We see we have a 9. The 9 does not have any left or right children, so left to right in order traversal. And now we're going to do the entire right subtree. So we get 15 to the in order 20 as that in order traversal that we were given. So we can see that that what they gave us was correct, but now the question remains, how can we actually take these two arrays, these two traversals, and construct this tree? Well, it's definitely possible. Let me show you how to do that right now. So I just want to let you know that there's actually two main facts that we're going to be using to construct this tree. So the first fact is that the first value in pre-order traversal is always going to be the root, right? We remember when we do pre-order traversal, right, we're always processing the root first. So if I was taking the pre-order traversal that we're given, right, we remember this is the pre-order traversal that we're given. The first value in pre-order traversal is always going to be the root. So this is the first value 3. It's guaranteed to be the root because that's how pre-order traversal works. The first value in pre-order traversal is always the root node. Now we don't know about the rest of these, right? But we can recursively construct now the left subtree and the right subtree, right? We're done with this 3, right? Now our goal is to reconstruct the left subtree. Hey, lucky for us, the first value here is always going to be the root of the left subtree, right? Because that's how pre-order traversal works, right? So that's one thing that we're going to use. The first value is always going to be the root, and then we can take the sublist, right? We can remove the 3. We don't need to look at it anymore. Then we take the sublist, and then basically we're going to do this recursively. That's what I'm telling you. Okay, we can construct the root, but we need more information than that, right? And then let's say we're done looking at this 3 now. I want to take this array, right? And I want to know which values are going to go in the left subtree and which are going to go in the right subtree. From looking at the actual tree itself, we know the answer, right? We know that this is where we're going to cut tree, right? How can we determine that? So now let's take a look at the value in the traversal and the pre-order. But okay, so far we know that this first value 3 is going to be the root, right? So now let's find 3, right? We know 3 is the root, right? So we removed it from our first list basically, right? But now let's find it in our in order list. We find it's right over here. 3 is in this index, right? So we know we don't need this 3 anymore, right? We already created that node. But so now what does this in order array tell us? Notice how this is convenient for us. Every value to the left of the 3 that we just created the root from, every value over here, which is only 9, is going to go in the left subtree, and every value to the right of 3 is going to go in the right subtree. That's really convenient for us. Why is this the case? Because that's basically the purpose of in order traversal, right? It guarantees that we're going to go through the tree in order, right? From left to right, basically, right? So if we see the 3 here, and this is the position in the array, we know everything here is going to be in the left subtree, everything here is going to be in the right subtree. That's what it tells us. This is really convenient for us because we can count it, right? We can see the tree, and there's exactly 3 values that are going to go in the right subtree. So what we can do is we can take the remainder of the pre-order. This is just like in the subtree now. So now we need to know which values are going to go in the left subtree and which are going to go in the right subtree. We know by finding 20, right? 20 is the value. Let's find 20 in our in order traversal. It's over here. By the way, in the code, I'm going to be calling the index of this mid. So M for mid. We find the index of 20. Right? We know we don't need 20 anymore, so we can get rid of it, right? We see that there's one value on the left of 20, and there's one value on the right of 20. This tells us that one value is going to go in the left subtree, and one value is going to go in the right subtree, right? Just like we have over here. So now let's construct that left subtree. Get rid of this code, value in our arrays, pre-order and in order. So
all right, I guess that's what I've done. Okay, he's done the same thing, I guess. Oh, it's not okay. His code is way shorter than mine. Cool. Let's see what he has done. Df is if the left is greater than right, returns null. Then you get pre-order. The pre-index. Get tree node, mid, and this is dot get root value. In order index element. Got it. Let's see.
So using these two arrays, we were able to create our tree correctly. And let me summarize what we're actually doing. What algorithm to create that way. So now let me actually, so base case is going to be, what if we don't have, we can return empty, null, we have no create a value that happens to be in the pre-order, index of it in of that value is the part where we're going to build the subtree. So root.left, let's create the left subtree, and we're going to do this recursively as I mentioned. So self.build tree, we're calling the function that we're inside of. And the convenient part about Python is we can do sublists, so that's going to cut down our code quite a bit. So we need to pass in the new pre-order and in-order arrays, or the subarrays more likely. So pre-order, what are we going to pass in for the left subtree of pre-order? Well, mid tells us how many nodes we want. The index of basically the value of mid tells us how many nodes we want in the left subtree. So what I'm going to do is for pre-order, we're going to start at index 1. We're basically skipping the 0 index because we already just created a node for the 0 index. We're starting at index 1, going all the way up until mid plus 1. In Python, this mid plus 1 is non-inclusive, so this subarray is really just a pre-order from index 1 in order from mid to basically reinvite sub to the right of mid in order, right? From our in order array, we want every value to the right of this index mid. So we can do that and then literally all you have to do, you could do this code without Python. It would probably just be a couple extra lines. You might need to pass in a couple extra parameters into this build tree function, basically just these indices that I'm doing. You might not be able to create sublists, but you can at least pass these indices into your functions in Java and other languages. So with that, we have actually created our tree. So the only thing left for us to do.
Got it. Let's do one more. Then we can move on to researching fine-tuning. Alright, path in the binary tree is a sequence of nodes where each pair of adjacent nodes in the sequence has an edge connecting them. A node can only appear in the outmost ones. The part on the path to the root. Alright, got it. You have to return maximum path sum. For example, here it will be 1527. Got it. What do we do here? Like, let's take this example. Of minus 10, 10, 9, 10, 20, 15, and 7. Alright, let's say we start with a DFS. With root, we have something called max sum. It's int min for now. Current sum is something you have. Current sum is minus 10. And then what you do is move to left. So minus 10 plus 9 plus 1. This returns your left sum. For right sum, you'll have something like minus 10. Then you go here. This has 10. 9. That is not how it works. what happens in this case? All right, got it. So ठीक है. We need to calculate left sum, then right sum. Okay, then we check what of them is max. Alright, then we add it with the current root ka value. So it's like calculate the maximum path sum of left subtree. It returns you 9 over here. Then calculate the maximum path sum of 20, this subtree. Then we go to this one. Then I get 15 from here. Alright, then I take from the right subtree. Right subtree gives me 7. Cool. Okay. Then these both come to my 20 root node, which is subroot node. Then what do I have is, right, I have right and left. I do a max, which becomes current max, and a right plus left plus root ka value. Cool. Then at the end, I return max of left comma right plus root dot. Is it how it works? For example, I go over here 15. There is no left to go, there is no right to go. Both return 0 0. Alright. Then I do update my max. Max becomes max of current max, and my root plus right plus left, which becomes 15 over here. My max current is updated to 15. Then it goes to 7. It again becomes 7. All right. Okay. So 15 is also current and is stored in left. Right is 7. Then comes to it comes 20. 20 case it becomes what? Max is equal to max of current plus comma 20 plus 15 plus 7. All right, got it. So and I will return max. All right, and the next thing I do is what do we do? Helper में what does it do? अच्छा नहीं, it goes with max dot max. ठीक है. What do I take max of current with? Let's take its max with 0. Reason being, I go to left, it's null, 0. It anyways will return 0 alright after, and with an idea helper dot left int dot right. Then the next thing is max becomes what happened in this case is very simple. Went to this left, again went left, gave me 0, right? Then I came over here, went right, gave me 0. Then I came over here, it gave me max, comma, right plus left plus root dot well, which becomes -9. And yeah, that's where I get my result from. So, alright, that's cool. Hey, hi, bro. Alright, enough Leetcode for today, I guess. Let's continue with our studying about finding LLMs. There's Matromax. Alright, plus left plus root dot val. Uh, I won't say pretty good at DSA because I generally look for solutions also. Like for this, I just watched the solution video to reconfirm my solution. Like it's just that I've solved these questions a lot of times. For example, if you see my submissions, yeah, I've solved it 11 times. Most of the things that I do for these is following neat code blind 75 or any neat code 150 sheet, or if you want any other sheet you can go for Striver's sheets, which is take you forward site. You can follow those sheets. But yeah, it's been a long time since I did some DSA, so yeah, I started to restart my DSA journey. And it's just that I've solved these questions a lot of times. That's why I get a bit of hunch sometimes, like how to do the question. So yeah, that's what I generally do. All right, let me close this. Read this actually. All right, I'll be not this. Wait a second. Uh, where is my? I just have to delete this. And another one. Not exactly new project, but it's just that I have to study a little bit about my office work about fine-tuning LLMs. So just thought about of like researching it on stream so that I can show how I generally search for new stuff that I'm about to do. And yeah, that's why I thought of reading on for these new fine-tuning LLMs on live stream. But yeah, it is quite possible I might use these techniques in some personal project in future. So yeah, all right. Just give me a second. I'll be back in 10 minutes. All right, I'll continue the stream in 10 minutes. So yep, let's okay. I didn't start with LLM actually as of now. As of now, I'm just studying about how to fine tune LLMs for our own use case, basically creating our own custom bot or AI model which is trained on your dataset. So yeah, I'll be continuing the stream in 5 minutes. Just give me some time. All right, let's continue. I guess. Wait a second. All right, cool. What the fuck is happening to the internet connection, man? Oh, why the fuck is this so slow? This is not expected. Come on. Why is it so slow? Yeah, alright, now it's fine, I guess. Cool. what those parameters are adjusted based on better understand and generate content relevant. second. Okay. Got it. Cool. Give me a second. All right. What do we have here? Got it. Got it. It is. Alright, let's continue this for another 5 to 10 minutes. Then I'll have to leave for some other work actually. What else will continue to? Alright, let's do one thing. Let's continue from here tomorrow. I have to leave for some other work actually for now. So yeah, that's it for today. Thanks for watching. Have a good night.